Hello everyone, this is for our bridging class. We will start with the following, that is on lecture 1, the real number system and the real numbers, also our number line. I'm Catherine Imerka from the Department of Mathematics and Statistics, College of Science and Math of MSU IIT. For our learning objective, you should be able to learn at the end of this lesson how to construct a number line and graph its points, use a number line to determine the order of real numbers, and to determine the opposite of a real number. The first definition is all about set. When you say set, it's actually a collection of well-defined objects. And within these braces, those are the elements of the set. For example, we have a set A which consists of red, green, and blue. This is a set of colors. When you say subset, it is a set consisting of elements that belong to a given set. For example, if we have set B, which consists of green and blue, then this is a subset of set A above. A set with no elements is what you call your empty set, and it is denoted by this one, this two braces which are empty, or this sign of an empty set. Now we next go to the following, that is about your special sets of numbers. The special sets of numbers consist of your set of natural number. The set of natural or counting numbers is denoted by n, and it is the set consisting of the numbers 1, 2, 3, 4, 5, and so on. You also have the set of whole numbers. The set of whole numbers would be your 0, 1, 2, 3, 4, 5. Notice that the set of natural numbers here is a subset of your whole numbers. Then we have the set of integers. The set of integers is denoted by Z. This one, Z, and it is the set consisting of negative numbers as well as your 0 and your positive whole numbers. So we have this. -3, you have your -2, -1, then your 0 is included, then you have 1, 2, 3, and down the line. Notice that the sets of natural and whole numbers are both subset of the set of your, this one, we have what we call your integers. For rational numbers, denoted by this time Q, this one, they are defined as any number of this form, A over B, where A and B are your integers. Your B is supposed to be non-zero. We have what we call your decimals that repeat or terminate. They are also called your rationals. So for example, we have the following. you have your 0.7 is equal to 7 over 10. And 0.3 with a bar would mean 3 is repeated all throughout. But 0.3 with a bar there, which is 0.3333, is actually equal to your 1/3. Again, this is a rational number. Note that we have what we call the set of integers is a subset of the set of rational numbers, since every integer can be expressed as a ratio of two integers, particularly the integer and 1 itself. So, for example, you have 5 equals 5 over 1. When you say irrational number, they are defined as any number that cannot be written as a ratio of two integers. So, we have what we call your non-terminating decimals that do not repeat. They are actually called irrational. For example, we have pi, which is the value 3.14159, and your square root of 2, which is equal to 1.41421, and so on. So when you say the set of real numbers denoted by R, we actually have here the set of all rational numbers combined with the set of all irrational numbers. So your real numbers consist of all rational numbers and all your irrational numbers. So all the numbers defined so far are actually subsets of your set of real numbers. Now, in summary, we have the following. First, you have what we call your natural numbers here. Your natural numbers, again, are your numbers 1, 2, 3, 4, and 5. They are also called your counting numbers. Your whole numbers start with 0, so that's why your natural number is actually a subset of your whole numbers. For the integers, you have your negative integers, the 0 integer, and the set 1, 2, down the line, or the positive integers. As for your rational number, you have a number which can be expressed as P over Q, where Q here should not be equal to 0. A over B, where B should not be equal to 0. Now, 0.63 is also another rational number, and 0.012, that means to say after this you repeat again 0, 1, 2, 0, 1, 2, and down the line. That means to say that this is actually a repeating decimal number. As for your irrational number, an example that was given earlier is square root of 2 and your pi. These numbers cannot be rewritten as a ratio. That's why they are called irrational numbers. And your rational and your irrational number is actually the entirety of your real numbers. Now, what do we have here? Your real number line. Your real number line would give us the opportunity to see the real numbers in such a way that we try to associate them with your points on the line. So these points is the point is called your coordinate, and the point in the real number line that is associated with coordinate is called its graph. How do we construct a number line? First, draw a horizontal line with arrows on both ends to indicate that it continues without bound. And then we choose any point to represent the number 0. And this number 0 is called your origin. So this is how we do it. First, we try to mark off the consistent lengths on both sides of the origin, and then try to label each streak mark to define the scale. So positive real numbers on the right of the origin and negative real numbers on the left of the origin. So this is how we do it. This one. So notice that this, if this is negative 2, that means to say this is negative 3. We divide this equally. These marks here, that one, and that 2. So this mark here belongs to 0, 1, 2, 3. This one means to say is a 2.5. So if we have a point here or a mark here, then this would be 2.75. So from here onwards, you will have your 3, 4, 4, 5, and down the line. And from here, you have negative 2, negative 3, and down the line. So we call this the real number line. What are the properties of your real numbers? So basic properties. If you have any real number a, b, and c, we have what we call your closure property. That means to say, if you have a and b to be element of your real number, then its sum is also an element of your real number. That's why it's called closure property. Also, its product of this real number will also be another real number. For commutative properties, it means to say that when you have a real number a, there, you have a real number a, and you try to add this with another real number, then if you add first a and your b, it will be the same as you add b first plus a. So, similarly, for your multiplication, we have what we call your commutative property for multiplication. That means to say, if we multiply a with b, it is the same as b times a. Another property would be your associative property. That is, you can actually multiply, add up a with b plus c, or we can add up a plus b first and then c, and that would be equal. On associative property of multiplication, that means when you multiply b with c first and multiply it with a, it's the same as associating a and b. That means to say you multiply a and b first, then multiply with c. You also have your distributive property. Your distributive property says that if you have a multiplied with b plus c, that's equal to a times, okay, multiply this one, a times b, plus add it with a times c, this one. And if you have A plus B times C, then that's the same